Hello, today we're gonna discuss that problem, 339 nested list weight sum. It's a problem asked at Meta. Um, the way it's sort of um, described on lead code, it's quite weird actually. As input, we receiving that array of um, nested integer nodes. That node has all those different methods to access all those numbers and um, nested uh, list. We need to call all those specific methods. We need to also check if that particular node is a list or if it's integer. So that there's kind of like there's lots of kind of complexity and weirdness around that extra class. Other than that, the problem is very easy. Just a regular DFS. We need to traverse over all those nodes. The only difficulty is to like understand that structure, and also understand that as an input we're getting actually a regular array. It's not a node, yeah, so we need to account for that. Okay. Yeah, when it comes to actual question, yeah, we just need to traverse through everything, and we need to keep track of the depth. So whatever is at the deeper depth gets more point. We essentially need to multiply that by that depth. So for example here, that's at those ones are at second level. We need to multiply them by 2 and add that to our sum. Yeah, that's pretty much it. We just need to traverse. Yeah, and remember that we traversing over very very weird structure called nested integer. Yeah. When it comes to time and space complexities, uh, we just need to traverse once over each node. So we can say that it's of n time. we, we're gonna keep, because gonna use recursion, so we're gonna keep that recursive stack on the memory, so that may add a little bit to our special space complexity. So that's why very often you may see that traversing over trees or graphs is actually of v plus e, which is v stands for verticals and e for edges. So that's more accurate description of the time complexity here, but I think we can say that it boils down to the amount of nodes. And when it comes to space, it will be pretty much depending on the depth. So we can say that of d where d is depth, because obviously if we have a tree which is very deep, we'll keep everything previously on the recursive stack. And that will be taking memory. If the tree is very broad, then we may have very little on the in the memory. So yeah, that's pretty much it. Yeah, we don't need any additional memory except for that. Okay, so let's start on it. Yeah, we just need to do regular DFS. So let's start it with that DFS, and we'll be traversing over over our, let's call it node or current node, and I'm gonna have also, we need to keep track of current depth. And now, because we're gonna have those arrays of those nodes, as a first condition we can check that if it's that array, And if it's another array, we can, you know, just iterate over each element of those arrays. So now if array is array current node, then let's iterate through that through each element of that array. So we can say, or we can use maybe that. Let's call it child of current node. Yeah, let's go deeper. And I'm gonna keep current depth here, because I'm gonna just I mean I could do it also at this level. I can add one. Yeah. Now if, and then we're gonna return. Now another thing is that our current node, you know, let's say we iterate over it, and the next node is the bottom node, which has the integer. So and there's a method exposed to check if it's a node holding that particular integer, and that method is called isInteger. So we can check that if current node is integer, then just then we can add those results to our final output. So I will have a variable holding that value, and now I'm gonna say that I'm gonna add to my result current node, and I need to use that method get integer. And that needs to be multiplied by current depth. Multiplied. And then we can return it because we get to the bottom. There's nothing nested further. But otherwise, there'll be, if it's not integer, it will be that list. It will be list which we need to access from that nested integer. So at the beginning we're getting a list, already extracted list, okay? But further down from the nodes we need to extract those lists ourselves. So we need to say that to get that list, like we can do it like that. Current node dot get list. And now obviously we could iterate over the list, but since we have we don't want to repeat ourselves, so we can just recursively pass it to DFS, and that condition will hit, and we're gonna iterate, you know, just without without repeating the same code. Now, and we need to pass the depth, or current depth. I could also be increasing here. I just need to, when I'm increasing the depth, I need to increase it only in one place. Yeah. And then we'll be returning result, and then we also need to run that function. Yeah. I'll start with 0. So now we can do a quick dry run. So we're iterating over that kind of nested list. So first thing which we hit is that array. Okay, so we would go here, and that condition would be triggered, and yeah, we're gonna go over each and every children of that first from that first level. That's first children, that's second children, that's third children. I'm gonna increase the depth by 1. Okay, then further, yeah, we have those. We have those 2 ones. Okay, so we triggered that function, and then that's our child. Then next time, that's not gonna be array, that's not gonna be integer, but that will be that list specific to that nested integer class. Okay, and then we're gonna essentially our code will go here, and we're gonna pass down the current depth, but then again we extract the actual array, and here we're gonna iterate over elements of that array. We're gonna increase now from 1 to 2, and then again on next iteration on next for each element we're gonna run that recursive function again, and this time our code will go into that condition, because those will be those singular elements, integers, and our for that particular element, for that first one, our current depth will be 2 at this point. We're going to extract our integer with that method, and we're going to add it to our results, and essentially we're going to repeat that for everything. Yeah, so feels to me like it should be working. Let's run that code. Okay, and let's submit. Okay, that worked. Yeah, as I said, yeah, time complexity is of n, it's linear. Yeah, we will be iterating over each and every element, and space kind of depends on the depth because of recursion. We'll keep our recursive calls on the stack, on the call stack, and that will use some level of memory. If our array is very deep, we can even run out of that memory. But yeah, that's pretty much the solution. Kind of the whole idea. The most important part obviously is to understand DFS, and I guess that's what interviewers should be testing. But the biggest difficulty is to understand actually that very weird class, and that as a first element you're actually getting already extracted array, and then you need to extract those arrays yourself. Yeah, so that's pretty much it. Thank you for listening, and see you again next.